Hey, what's up, everybody? Mark Price here at devslopes.com, and today we're going to talk about numbers. You're like, wait a minute, I thought we were doing programming. What the heck are we doing? Going back to like 5th grade math, first grade, whenever you learn about numbers, probably in kindergarten. Yeah, that's right. Today's episode is brought to you by the number 3. Okay, so really though, open up your Xcode beta and create a new playground if you're following along. Otherwise, you can just watch. And we're going to call this one numbers. And I'm going to create a new folder for it here. It's always nice to organize your code and projects into folders, Swift, and this one's going to be called numbers. We're going to save it here. So numbers are a core foundational building block to any programming language. And when you think about it, you interact with numbers all the time in any application that you're using. For instance, if you go to wellsfargo.com to log into your bank account, you're going to see your bank account balance, and it has numbers in it, okay? If you are using a workout app, and one week you weighed like 150 pounds, and then the next week you weighed 170 pounds, because who knows what you're doing with yourself? You have to use numbers to show that to the user. Numbers are everywhere, and it had to do math in order to calculate how many calories you consumed, and all those different things. So numbers are everywhere in every application, just like this is a string and there's words and applications, okay? Use numbers and use words. I know it sounds basic, but those are foundational variable types in any language, but there's different types of numbers. So let's get rid of this string variable here, and let's create a new variable. Okay, so numbers, right? Now, we don't just say var some number, equals number. There's no, what is a number? There's no real number, okay? What you have to do is actually create different types of numbers, such as integers, floats, and doubles, and there's more. So, for instance, if we're a person, right? A program for a person. Maybe this is one of those apps that calculates and tracks calorie burning and things like that. Shows you how much junk food you're eating, So let's go ahead and say, well, we have to have a profile, so we have an age, right? Or not. There we go. A person has an age, so we'll say age 30. Okay. And let's say var weight. We'll just do pounds. That's how we roll in the US of A. Weight equals, we're going to say 200. So this person weighs 200 pounds, okay? Does anyone know what variable type this is? Okay. Well, these are actually called int or integers, but in Swift, the keyword is actually int, like so. So what we can do here is I can put a colon here, and then I can put in the keyword int, the variable name. And what we're doing right here is creating an explicitly declared type. Before, we were creating a variable with an inferred type, meaning the variable is smart enough to know what you're putting in it, and so it knows that it's an int. For instance, I can't say age equals peanuts, like if I want to try and break the program. Look at that. Cannot assign value of type string to type int. Okay, so you cannot put different data types inside of a variable, and it was smart enough to know that this was an int. So this is the keyword here, okay? This is an inferred, or let's just call this type inference. There we go. That's the proper term. Type inference. It inferred what type it was. It's no different than this, except it did it automatically. And by the way, this is the recommended way in Swift. If at all possible, use type inference. And if you have to use an explicit declaration, do it. Don't just do this because you think it looks nicer. That's not the Swift way. The Swift way is like this. But this is an explicitly declared type, okay? So this is an explicitly declared type. Those are the keywords and phrase right there. Explicitly declared, because we actually wrote what type it was. And again, the same thing here. We can't say weight equals no weight. Right? We can't spell either. That's why we need to work with numbers. Okay, so we can't do it, right? So same exact thing, no difference. So pretty cool. So we've got some ints here. And what is an integer? Okay, what is an integer? Well, let's go pull open the Swift book if you don't have it already. And if you don't have it, please get it. Go to iBooks. This is super important. Get this book if you don't have it. I said go to iBooks. We're already in iBooks. and then do a search for Swift, not Dora the Explorer. Dora meets Pablo, that's my personal reading. Just forget that you saw that. And the Swift programming link, how did that get on here? Anyway, Swift 3 edition is the one that you want. It's right here. Don't do the one with Cocoa and Objective-C. Do this one right here, and get that book and read through the entire thing. I promise you won't regret it, and it'll make you a much better programmer. So, integers are whole numbers with no fractional components, such as 42 and negative 23. Integers are either signed, positive, 0, or negative, or unsigned, positive, or 0. Swift provides signed and unsigned integers in 8, 16, 32, and 64-bit forms. And what that means is 64-bit, 32-bit, it's how many characters, how many digits it can hold, the actual value. You know, if someone had $1 trillion bank account, you're probably not gonna be able to use this 8-bit integer. You're gonna use something larger, but Swift is smart enough to do all that for you automatically. Just know that there's some different things going on under the hood. And so you can see some of the types here, like uint 8, okay, and a 32-bit signed integer is of type int32. So it depends. It shows how much it holds. Again, you don't ever need to worry about this, and pretty much in Swift, for the most part, you're never ever gonna have to do anything else except this standard int. Okay, but again, you can do different things. Some num, and you could say uint. Where is it? Uint 8, 16, 32, 64. You can do different things like that. Okay. But you want to be careful. You don't want to do something that you can't do because it'll overflow the variable. Integer literal overflows when stored into UA. It's too big of a number. And so again, don't play around with these. Don't be like, oh, I want to be more memory efficient and use smaller integers. No, don't do that. Always use int. Okay. Always use an integer. And I think actually this one's too big even for an integer. So in this case, you probably have to use a data type that's even longer, like a long or something. Of Swift, I think just a double. Would that do the trick? There we go. Doubles, double precision, twice as long, more or less. Anyway. That is another data type, which allows you to have incredibly long values here. Okay, look at this. This is just huge. I don't even know what number that is. Okay, so we have integer, which you want to use at any given time. If a number does not have decimal points, okay, no dot, whatever, you want to use int. Okay, always use int. If you need a long number, double is the favorite choice here. Okay, so you can also, on a double, this is cool. If you had something like, let's say, a bank account, right? So actually, no, we're doing, what are we doing here? We're doing an exercise app. So let's say miles ran, okay? Var miles ran, and we ran equals, we've run in the whole week 56.45 miles. So what type is this? This is actually a double. That's pretty cool. So by default, Swift uses doubles, which has double the precision. In fact, let's pull open our handy dandy iBook. You're like, I didn't pay X amount of dollars for this course so you can read a book to me. I wanted you to say those words without looking at a book. Does that make any sense? No. It's better to have it straight from the horse's mouth. And I do this a lot. Okay, get used to it. It is so important to read the documentation. Like, seriously, if you go to your boss every single day, you're like, how do you do this? How do you do this? He's going to fire you. I wouldn't have an employee like that. You got to learn how to learn. So always go back to the documentation. I'm trying to train you here how to become a lifelong learner and programmer. So where was I before I started lecturing you on things you don't even care about? Okay, so we talked about integers. Okay, floating point numbers. Floating point numbers are numbers with a fractional component such as 3.14. And maybe you're thinking, wait, you just did a double. Why didn't we do a float with the decimals? Well, read this. Double has a precision of at least 15 decimal digits. Okay, so 15 decimal digits, whereas the precision of a float can be as little as 6 decimal digits. The appropriate floating point type to use depends on the nature and range of values you need to work with in your code. In situations where either type would be appropriate, double is preferred. Okay, so by default, Swift uses double. Okay, as you can tell, it's a 64-bit floating point number, very long. A float cannot be as big. And maybe you're thinking, well, I should make the numbers I should save memory by using a float instead of a double. No, Swift is highly optimized under the hood, and it recommends that you use double over float at any given time. So don't use a float unless you absolutely have to, whereas in other languages, float is the keyword. In Swift, always use double. Double, double, double. Okay? So, and just to show you that this is a double by default, if we did create a float, let's say var pi equals 3.14, okay? And then I say miles ran equals pi. I ran for pi. Let's see what happens. Actually, this is going to work because the double, the float will convert to a double. What I meant to do was pi equals miles run. Actually, it works interchangeably. News to me. Okay, so this is definitely a float, though. Oh, that's why. Okay, guys, I'm not smoking crack. I promise. This is a. It's because it was both a double. I'm like tripping out. Why is it not working? Okay, so there we go. Okay, so pi is a float. Here we go. Cannot assign value of type double to type float. So clearly this is a double, and clearly this is a float. So the point I was trying to make is by default, it always chooses a double when you use the decimal points. And so when you're creating your apps, you're only going to really ever use ints and doubles for the most part when you're working with numbers, which is really cool. And I encourage you to actually read a whole lot more in this Swift iBook about, well, wherever it went, about all these different things, because it has incredibly valuable information, incredibly valuable. And it's actually written with the proper keywords, because sometimes you may hear an instructor or somebody talking about programming in general. They're not using the right terms. They're summarizing it. Swift actually, in those books, they actually use the right keywords, and they teach you what's going on under the hood in a lot of cases. So this is numbers, right? And you can do a lot of things with numbers. And we talked in an earlier video about operators. You're going to use what's called arithmetic. Oh my gosh, I'm sorry. I just arithmetic. All right, woo, arithmetic. Arithmetic operators. If you're new to the class and you're wondering, like, why does he leave some of this stuff in here? Like, why do we make mistakes and things like that? And what happened was, in the beginning, I didn't always do that. I kind of cleaned up the code, and made it look perfect. But all the students were like, "You're doing it so perfectly. You're just so amazing. I'm never going to be a programmer because I can't do it perfectly like you." And I was like, guys and gals, I'm not doing it perfectly. This is all edited. So I started making videos that were real, like how programmers really solve problems. And then everyone's like, I can do this. Mark Price he's not a robot. He's a real person who has to figure things out and use his brain. And that's why we do these things. That's why these videos are so informal, because I pretend that you're sitting here right next to me in the class, so I can actually teach and convey a message to you. So again, if you're new to all this, this is how we do it over at DevSlopes, and it's exciting and people love it. If you hate it, I'm sorry, just love it. Okay, so arithmetic operators, and this is just like in math in like high school, right? Or grade school even, right? You got plus, minus, divide, multiplication, okay, things like that. And so you can actually play around with numbers, which is kind of cool. One of my favorite ones is doing the area of a shape, a rectangle. So var area equals, and let's say length, so 15 times width, 20. Okay, and we just did multiplication, 315 times 20, which is really cool. And we can do addition as well. Var sum equals 5 plus 6. Var diff for difference equals 10 minus 3, 32. 10 minus 3. And so we're doing different operations here, which is really cool. What about division? Can we do division? Well, yes, we can. We can say, let's say 12 divided by, do some division. 12 divided by 3 is 4. Okay. But there's one more thing I want to show you. Okay. What if we said var divide, and we said, what is 12 divided by 5? What do you think it's going to be? Oops. Div1 equals 12 divided by 5. Again, these are just container names we're giving them, okay? So, wait a minute. 12 divided by 5 is not 2. Where's the remainder? There's got to be a remainder. Well, in Swift and pretty much every other programming language, division, or the arithmetic operator for division, this backslash here, it is only going to do the division and only give you how many times it goes into a number. The remainder actually is not going to be provided to you. So to get the remainder, you actually have to use what's called the remainder operator, or modulo or modulus. I've heard people say all kinds of things. You can call it the modulo operator is commonly used, or the remainder operator. That's what Swift calls it, remainder operator. So the remainder operator is this, equals 12% sign 5. Okay, so which is 2. There's 2 of a remainder. Okay, right? So 5 goes into 12 2 times with the remainder of 2. Let's do 13 just to show you that these are different numbers here. Okay, so if I wanted to show the full problem, okay, I could do something like this: var result equals, this is gonna be a string, right? So the result of 13 divided by 5 is, okay, we can use string interpolation here, okay, to insert a variable in, and we can say div1, and then we'll say dot for the decimal, right, with a remainder of, well, that's not really, the dot's not really appropriate. 5 is with a remainder of, there we go, and then we'll put in the remainder. Okay, so the result of 13 divided by 5 is 2 with a remainder of 3. Okay, and don't worry if you don't understand all this just yet. I'm just inserting variables into my string here so they'll print out to the screen. So what happens with the remainder operator is it's going to do the division, but instead of returning the first number, it's going to return the remainder if there is a remainder. And this is a great way to determine what numbers are even or odd. Even numbers will have no remainder, right? So if I wanted to know if a number was even or odd, so let's say var random number equals 13. So we could say if random number modulo 2 equals 0, so the double equal sign, is this something true or false, you know, or is this equal to that? It's going to give you a Boolean value. So if random number modulo or remainder operator 2 equals 0, okay, you know, we'll print this is an even number. All right, else, okay, print this is an odd number. Okay, and so look, it's printing up this is an odd number, but what if we turn this to 12? Okay, so this is an even number. So this is something that is very commonly used to determine whether numbers are even or odd, is this remainder operator. So you've done some basic arithmetic. We've talked about different types here like int, double, and float. You can use negative numbers. You can use positive numbers. You can do all kinds of fun things, all right? And by the way, this right here, this is a unary operator, kind of like what we've talked about in the past. It's operating on one target here, making it a negative number here, just so you know. Little tip and trick right there. And so don't worry too much about the ifs and else if you don't understand that just yet, or the string interpolation that we used here. The point of this lesson is to talk about numbers. You can do math operations, and of course, order of operations are all followed in Swift, as well as most other programming languages. So I could say var result 2 equals, let's say 15 times 5 plus 7 divided by 3, right? And if I wanted 5 and 7 to be done first, and then I wanted the result of this to be done next, I could do something like that. So just like you do in math, like in high school, the order of operations you know, still applies, the same that you would do in math in high school, and you can use parentheses just like you would do in high school math to get the results that you are looking for. And again, this is very foundational. Every app you've ever used uses math like this. When you're swiping your card at a bank and it wants to deduct money, it's got to use math to take money out of your bank account, things like that. So you have now used a basic foundational thing that you're going to use for the rest of your life as a programmer and in every app that you'll ever build. So that's it. Numbers. Mark Price at devslopes.com. See you next time.